Hey gang, I'm Professor Feeser and I do on-site and online training for large organizations. But once a month, I'll do a public class online. Subjects might be programming, AI, cloud, or telecom like SIP. If you're interested or trying to source training for yourself or perhaps a large organization, I have lots of my contact info on the screen. Feel free to reach out and we can definitely start a conversation about your training needs. Today we're going to talk about SIP response codes, Session Initiation Protocol response codes. Specifically, what kind of response code should be sent back to an invite? So invites make phones ring. And a 4XX is a type of failure, just like a 6XX is a type of failure, but they mean wildly different things. We're going to study the RFC. I'm going to show you or explain a lab demonstration, and then we're going to watch the lab demonstration live. We'll back that up with a PCAP trace so we can see exactly actually what happened. And we're going to do that twice. We're going to do it in lab where we have 4XX responses being sent back to an invite. And we'll do it again where we send a 6XX back to the invite. And we'll compare, contrast what the results were. So let's get started with defining 4XX responses from SIP RFC 3261. On page 188 of RFC 3261, which is the core RFC that teaches us how SIP functions. It was written 20 years ago. It's still the standard for learning about how SIP functions. On page 188, they teach us about a 486, which is a 4XX type response. It's in the 400 series. That's what we mean when we say 4XX. We mean any 400 type code. This one specifically, look what I have highlighted in red. The user could be available elsewhere. So if somebody sends you an invite and you send back a 486, you're saying, hey, I'm just right here is a no-go. Now, there may be other handsets ringing. I may have a voicemail service, and all that's okay. You can keep searching for me other places, but here I am busy. Now read that last sentence. It says status 600 busy everywhere should be used if the client knows that no other end system will be able to accept this call. I would interpret that slightly differently. How about 600 should be used if the client wants to shut down a continued search for them. You don't want them to leave a voicemail. You don't want them to keep ringing your phones. We'll see a 600 in action, but let's watch first what a 486 would do in a lab environment. Gang, here's the lab setup I have for us. It's 4 phones, although there's only 2 extensions that are registered, a 1011 and a 1012. In this case, 1012 is going to be Alice, the caller. 1012 will call 1011. Camelio, our SIP proxy registrar, has Wireshark running in it, so we can intercept all of the traffic coming in and out. We're going to see an invite actually get passed up to Camelio. Now remember, Camelio is holding registrations. It's the registrar. It knows about everybody in the picture. So it says, hey, an invite to 1011, I got 3 IP addresses for that. So it's going to fork. It will make 3 copies of the invite. The only difference will be each via header will be slightly different. All 3 phones are ringing. 1011 in all places are ringing. We're waiting for somebody to pick up. We can only have one person pick up. SIP is an Alice Bob protocol. Now, if you're going to have conference, you got to have a conference bridge. So who is going to pick up? Well, the 180 comes back. The 180 means endpoints ringing, and Camelio or just any proxy or back-to-back UA could do response merging. It could say we only need to send a single 180 back to 1012. It also might send all 3. All 3 might go back, in which case Okay, they all have different to headers. Would be probably the only distinguishable. Well, contact headers would be different if they exist. There's the 486 though. That's the soft phone saying, I'm out. And you hit the decline button typically. When you get a call and you see decline or don't pick up or whatever, screen, that's going to be a 486. It's not, there is a 600 code called decline. That's wrong. Unless you want to stop all other phones from ringing, got to be a 400 code. 486, busy here. So just think about SIP. In SIP, we have an invite, we have a final response, you must send an ACK. So Camelio, or at least 1012, owes an ACK to 1011. The thing is, 1012, the Linksys phone, doesn't know that there's a forking situation going on. That was actually Camelio created the fork. So what we see next there, the ACK being sent by Camelio, it's created by Camelio. Downstream, 1012 doesn't know that there's multiple phones ringing. Somebody picked up. I see a 200 sent from the grand stream. Did you catch that? 1011 sent a 200. That means we can answer the call here. Well, we have a problem, right? First problem is 1012 owes an ACK to the grand stream. Second problem is Linksys 942 on the far left. It's still ringing. So it's kind of bizarre, but think about this. Alice sends an invite to Bob. And now Alice wants to stop the phone ringing. That's bizarre. Well, Alice can't really retract the invite. It needs a final response from Bob. That's the way the protocol works. And Alice has to send an ACK. So we're still waiting for a final response from Bob. And we need a ACK. So what Alice can do is send Bob a cancel. Bob will send a 200 to the cancel. And then Bob sends a 487, which is the final response to the invite and acknowledges, hey, Alice, you tore this call down. There's the cancel. So now there's an invite pending, there's a cancel pending. That 200 is to the cancel. That 487 is to the invite. Now what are we left with? An ACK. We still have to send an ACK. Okay. Now the phone on the left is taken care of. And all that we have left is that ACK and RTP cut through to the two phones, Alice 1012 and 1011, the grand stream that actually picked up. Okay, gang, so this is our lab setup. There's the 4 phones as described. The soft phone, obviously, on the right. Wireshark's running in the background. So Alice makes the call. You see all 3 phones start ringing. We decline it. The 486 is produced. But other endpoints continue to ring. See that? Once I picked up, that stopped the phone on the far left. That's because somebody answered. Notice the 486 allowed other endpoints to continue to ring. Hey gang, this is the 486. So in this call, we see the invite go out. It gets challenged. The invite is forked. See how one invite turned into 3 invites. We see a bunch of 180s. That's all the endpoints sending back 180s. There's the 486. And you'll see the behavior of, okay, no problem. We're going to continue to let endpoints ring until a 200 to an invite is produced. A cancel needs to be sent to the endpoint that's still ringing and didn't pick up. A bunch of ACKs. There's the 487 to the invite that says I was canceled. There's the 200. Some talk time. It looks like about 3 seconds or so until the buy is sent. That, I think, picked up the phone. Must have been about 2.5, 3 seconds before I hung it up. So I had some fun with this. This is a 6XX description where you can see not Superman, but Professor Feeser's SIP-Man is fighting Doomsday. SIP-Man, of course, builds SIP dialogues. SIP dialogues when two calls start a conversation. Well, a 6XX response will prevent that. It will destroy a SIP dialogue from ever being created, and same way Doomsday was bad news for Superman. So the 6XXs are called global failures. Doomsday responses are fine as well. We hear both terms out in the wild. Looking at the RFC, 6XXs in general are definitive information about a particular user. That's on 191. And then it goes on to describe a 603 decline. The 603 decline, look what it says in red. This status response is returned only if the client knows that no other endpoint will answer the request. It shuts down a search. So if you have multiple phones ringing and one of them sends back a 6XX, like we just saw, all phones are going to stop ringing. In this case, the proxy would interpret that as, uh-oh, the caller's bad news. Here's why I discovered in the wild a 603 decline, which is what we're about to see. It's up to some developer to come up with SIP stacks. And this particular SIP phone, Lin phone, it's a free soft phone. They had some SIP developer who was told, we're going to have two buttons. One is answer, which they figured out, send a 200 back. But they also said there's a red button that's going to say decline. And no fault really of the developer other than them not being a SIP wizard. They looked across the available response codes and said, hey, look at that, a 603 decline. That must be what you send back when somebody presses the decline button. So what LinPhone rolled out, I have no idea if they fixed this. I played around with this software years ago. But what they rolled out was a soft phone that when you said, I don't want to answer this call, it sent back a 603, with a big decline, red decline button. So let's go ahead and see that in action. We're going to look at the exact same experiment, but we're going to use this faulty Lin phone and see how a 6XX response completely changes the call flow. You remember this scene. This is the same lab setup. The only difference is we have a different soft phone here. We've replaced our soft phone now with Lin phone, which is the one that has a faulty SIP stack in it. When you hit the decline button, it sends back a 603, not a 486 like we would expect. So in this case, again, 1012 sends that invite out, and it gets forked 3 different ways because of the 3 different registrations. 3 180s come back that indicate ringing. But the soft phone is going to say decline. We can pretend this is somebody who's out with an important customer. They'll let the office get the call. So there's the 603 coming back. Camellia manufactures an ACK and says, okay, invite 603. There's only one thing you could possibly get, which is an ACK. So the Lin phone's out. It's now going to manufacture 2 cancels, and it's going to fire those to the other 2 endpoints that are running because the 603 meant do stop searching for me. 1011 doesn't want to talk to 1012. 200s come back to the cancel. 487 comes back to the invite. In this case, then a 603 sends back to the Alice caller. There's the ACK. There's the 603 to the Alice caller who sends the ACK, but the ACK's already been sent to the Lin phones. They're out. Wildly different behavior, right? It's probable that the feature we wanted was other endpoints to continue ringing, that we wanted voicemail potentially to be found, but that 603 totally shut things down. If you're going to use that, you're going to see it in a situation with call blocking. Somebody says, hey, this is somebody calling, abusing my number. When they call in, I don't even let them leave a message. The phone system, the IMS, an application server, will just zap it with a 600 and they not even get to leave a voicemail. So gang, this is the experiment with the 603. Same phone layout, except the soft phone's replaced with Lin phone, the one with the faulty SIP stack. Call goes out, Wireshark lights up. You'll see on the soft phone, I'm going to hit decline. And all the endpoints stopped ringing. That's because the 603 meant stop searching for me. So gang, the analysis of this PCAP is going to be a bit faster, huh? There's the invite, it gets challenged. The invite is fort, so we see 3 invites. There's the bunch of 180s coming back. 603 decline. Cancels are generated, multiple cancels. 487, I understand. 487, I understand I was canceled. 603 is sent back to the original sender, Alice. The ACK is sent from Alice to Camelio, and that's it. There's only 29 packets because of that 603. So gang, to recap, a 486 is typically what a phone's going to send back, even if there's not call forking involved. Somebody calls your cell phone, you hit, I'm busy right now, I want to talk to this person. 486, right? It lets them leave a voicemail. The 603 or any 600 code for that matter is probably only going to be sent or should be sent by the phone provider, right? So an AT&T, Verizon, T-Mobile. And that would be involved with something like a call blocking scenario where you get into your profile, you say, hey, this person harasses me. I'm not interested in these digits being able to contact me. They zap them with the 603 before they're even allowed to ring your phone, right? And it lets everybody involved, all networks involved, know. We're not leaving a message. We're not looking for additional endpoints to ring. The call is over. Gang, if you're looking for training, I have all sorts of contact information on the screen. If you need a consultant, something about telecom, feel free to reach out. If you learned something today, give me a like, hit subscribe so I can see you in the next episode of Code with Feeser.